5, 4, 3, 2, 1.
In this video tutorial, we're reviewing the idea of sequences. A sequence is a set of items which follows some rule or order. We could also say, or pattern. Some examples. There are number patterns, there are also shape patterns. The second example is a matchstick puzzle where 2 additional matches are being added each time. The last two, the Fibonacci and the Lucas sequences, are quite interesting, and we will return to them later in the course. Each item in a sequence is called a term, and we label each term with a number to identify its position. Realize that the number is a subscript. Make sure you write it as a smaller number just below the line. And in general, any position of a term is known as the nth term. Think of n as an index number which identifies the position of the term within the sequence. We can also look at the next term up, which is simply found by adding 1 to the index number n. So if we're looking at term tn, the nth term, the next term is going to be called tn plus 1. The previous term we will subtract 1 from the index number, and that will be tn minus 1. Example 1, we have a simple sequence. Have a quick look at the pattern. Hopefully you'll see easily that we're doubling the number each time. To find t4, we simply count to the 4th position in the sequence, and the answer is 56. We can also perform normal arithmetic on terms. So t1 plus t3, all we do is identify those 2 terms by their index number, by their position, and add them together. So the answer is 35. We can multiply terms as well. t2 is 14, so 3 times t2 is just 42. In part D, we're going to write down tn where n equals 2, so that's t2, and the value is 14. Now the last one requires us to do a bit more thinking. t6 squared. Firstly, note that it is not the 6 that is squared, it is the whole term. In other words, the 6th term in the sequence is being squared. So we're going to square the term, which is t6 times t6. But before we go any further, we need to identify and work out what the 6th term is. We only have up to the 4th term listed, so we need to double 56, and we need to double that again to find the 6th term, which is 224. So the answer is 224 squared, or 50,176. The next big idea is recursive rules. This is a way of describing how the next term in a sequence is obtained. Example 2. We have a sequence 10, 14, 18, etc. and we can see that we're adding 4 each time. In other words, the next term is equal to the current term plus 4. So mathematically, one way of expressing that is to say that tn plus 1, in other words the next term, is equal to the current term plus another 4. We can always write the whole sequence of terms just by adding 1 to the index as we move to the right, and progressively subtracting 1 from the index as we move to the left. Just to quickly recap, tn plus 1 is the next term, and tn is the current term. Another way of expressing the above sequence is tn equals tn minus 1 plus 4. So in other words, we're defining the current term tn by looking at what we need to do to the previous term tn minus 1. Now, a very important skill for us is to learn how to rewrite a sequence by manipulating the index numbers. So if we start with tn plus 1 equals tn plus 4, how do we rewrite that to give us an expression for tn? Well, what we need to do is subtract 1 from the index number of every term. So I've shown that in red. Tn plus 1, we simply subtract 1, and that gives us tn, because 1 minus 1 is 0. And then on the other side, tn has become tn minus 1, and then we simply add on the 4 on the end. So that expression is identical to the previous one, just a different way of writing the same sequence. Any rule that links two or more consecutive terms in a sequence is called a recursive rule. Simply means that the same pattern is repeating. Means that we can find later terms if we know the previous terms. And you should realize here that such a rule does not allow you to immediately determine any number in a sequence. For instance, to find T11 in the above recursive rule, you need to know what T10 is. Now if Tn equals Tn minus 1 plus 4 was written as Tn minus 1 equals 4, then we have a difference rule. A difference rule gives the difference between consecutive terms. Example 3. Find the first 5 terms of a sequence defined recursively as follows. So here we have Tn defined in terms of the previous term, which is being squared, and then 1 is subtracted from that, and we're told that the first term is 3. So what we need to do is start with n equals 1 and do a little bit of algebra. So first of all, we know that T1 equals 3, but if we replace n with 1 in the sequence, we can also write T1 minus 1 squared minus 1 equals 3. And of course 1 minus 1 is 0, so that means the initial term T0 squared will equal 4. We add 1 to both sides, and then we find the square root of 4, and that gives us T0 equals 2. T2, again substitute n into the sequence, and that's T2 minus 1 squared minus 1, which of course is just the first term squared minus 1. Now you can see there that the second term is the previous term squared minus 1. We know that T1 is 3, so T2 must be 8. The pattern should be coming fairly obvious now, so let's just jump straight to it. T3 equals T2 squared minus 1, which is 8 squared minus 1, or 63. T4 is T3 squared minus 1, which is 63 squared minus 1, giving 3,968. And finally, T5 equals T4 squared minus 1, which gives this rather large number.